We are going to start now the lecture 5 of chapter 7, class 11 mathematics, permutation and combinations. In this lecture, we will talk about permutations with repetitions. So the first formula we have, it is, suppose we have the n different objects and r of them are taken at a time. So when we are saying that r are taken at a time, this thing is just, we are saying it is equivalent to saying the number of ways of filling up r places with n different objects. But it is important to note over here that the repetition of these objects may be repeated any number of times. So if we try to explain this, we are saying we are having r places 1, 2, say so on up to r places, and there are n different objects. We are having the objects 1, 2, 3, 4, so on up to n, and we want to fill these places, and we can use these objects repeatedly. We are talking about this case. Then we are saying that we have total n raised to the power r arrangements. So how we are getting the answer? We are saying if we want to fill this first place, we can fill with any one of these n items. So we are saying there are total n options out of which it is to be filled. Then this second place is to be filled with n options. Then continuing in this way, this rth place can be filled in n with any of these n options. So the product of all these terms, it is n raised to the power r. So we are saying that the required number of ways, it is n raised to the power r. And if n is equal to r, that is the number of permutation of n different objects taken all at a time, when each may be repeated any number of times, then the answer we have, it is n raised to the power n. So the first question based upon this is, in how many ways can 4 letters be posted in 3 letter boxes? So we have, these are 3 letter boxes and we have 4 letters. These are 4 letters that we have. This is 1, 2, 3 and 4. Now we are saying this first letter we are talking about, it can be posted in any one of these 3 boxes. So the number of ways of posting this first letter, it is 3. Similarly, this second letter we are talking about, it can be posted in any of these 3. The number of ways we have, it is again 3. Then we are saying this third letter we are talking about, it can be posted in any of these 3. The number of ways, it is 3. And this last fourth letter, it can be posted in any of these 3. So we are saying it is 3 raised to the power 4, that is equal to 81 ways. Next question we have is, in how many ways can 6 different rings can be worn in 4 fingers of the hand? So we are saying that each of these rings may be worn in any of the 4 fingers. So each ring may be worn in 4 ways. We are saying we are having 6 rings and each of these rings can be worn in 4 ways. So the total number of ways we have, it is 4 into 4 into, we are talking about the first ring, it can be worn in 4 ways. The second ring can be worn in 4 ways, and likewise we are saying the sixth ring can be worn in 4 ways. So we are saying the total number of ways we have, it is 4 raised to the power 6, that is equal to 4096. Next is, in how many ways can 5 apples be distributed among 6 boys, there being no restriction to the number of apples each boy may get? So in this case, we are saying that each of the apple we are talking about, that each apple may be given to any of 6 boys. Number of apples we are having, it is 5. We are saying the first apple, the option, number of options we have, it is 6 options, 6 boys we have. For the second apple, we are saying we have 6 options. For the third apple, we are saying we have 6 options. Likewise, continuing for the fifth apple, we are saying we have 6 options. So the total number of ways we have, it is product of all these, and the product of all these is equal to 6 raised to the power 5 that is equal to 7776 ways. We have total 7776 ways. Next is, in how many ways can 3 prizes be distributed among 4 boys? So we are having the case over here that we have 3 prizes and the number of boys we have, it is 4 boys. So if we are talking about the total number of cases over here, it will be, so one of these prizes we are saying, the first prize, it may be given to 4 boys, any of these 4. We are saying we have the second prize, it may be given to any of these 4 boys, we have 4 options, and the third prize we are saying it may be given to any of these 4 boys. So the total number of options we have, it is 4 into 4 into 4, that is equal to 64. Now in the first part, it is no boy gets more than one prize. So if we are having this, we are talking about this first case that no boy gets more than one prize. So we are saying that the first prize, it may be given to any of these 4. Now one of them has taken the first prize, so the second can be given to any one of the remaining 3, and the third prize may be given to any one of the remaining 2. So the total number of prizes we have, it is 4, total number of choices we have, it is 4 into 3 into 2, and the answer we obtain, it is 24. The second case we have is, a boy may get any number of prizes. So this case we have already seen that 3 prizes are there and 4 boys are there. So the total number of options we have, it is 64. So we are saying we have total 64 options. And the last case we have, it is no boy gets all the prizes. So we are talking about the total number of options we have, it is 64. These are the total options we can have. Now suppose we are counting the option that all prizes goes to one boy. We are talking about all prizes, it goes to one boy. Number of ways of doing this, it is, the number of boys we have, it is 4, that any one of these 4 boys may get all the prizes. Now look at these two conditions. We are saying the total options we have, it is 64 and 4 options are there. We are saying all prizes goes to one boy. So the number of ways in which a boy does not get all the prizes, it is equal to 64 minus 4, that is equal to 60. So these are the answers in these 3 cases. Next is how many 4-digit numbers can be formed from the digits. We have total 6 digits given to us. So we are saying that thousands place can be filled in. We are having 4-digit number. This thousands place, it can be filled in 6 ways. This can be filled in 6 ways. This can be filled in 6 ways. This can be filled in 6 ways. So the total number of options we will have over here, it is 1, 2, 9, 6. Next is how many 4-digit numbers are there when a digit may be repeated any number of times. So we are talking about 4-digit numbers. So suppose we are saying we have a 4-digit number over here. Now for this place we have 9 options because 0 cannot be there, and for remaining these 3 we are having 10 options. It is 10 into 10 into 10. Any of the digits 0 to 9 can be filled over here. So the total number of options we have, it is 9000. These are the total number of options that we can have. Next is circular permutations. So till now what we have studied is, we are saying that the arrangements we are having, they are objects we are arranging in a line, and these arrangements, these are called linear permutations. Now in place of this we are arranging them in the form of a circle, and these are called circular permutations. So if we are talking about this case that linear permutations, we are talking about A, B, C, D, B, C, D, A, C, D, A, B and D, A, B, C. Then these are all distinct. But if in case of circular permutations, we are saying that we are arranging them on a circle, but we can see it is A, B, C, D. This next is A, B, C, D. Next is A, B, C, D. This next is A, B, C, D. So all these four, they are representing the same kind of arrangement. All these four we are saying, these are representing the same arrangements when we are arranging these objects A, B, C, D along the circumference of a circle. So we are saying that if we consider the position of an object relative to other, then we find that all these above arrangements, all these four arrangements, they are same. So we can understand this situation in the way that if A, B, C, D, they sit around a table, and once they are being settled, we are asking them to, all of them, to shift to the chair to the left, on their left. We are asking them to shift on the chair on their left. So we are just trying to rotate those persons, but the arrangement, the final arrangement they are generating, they are the same. So we are saying in circular permutations, we fix the position of one of the objects, and then arrange the other objects in all possible ways, because if we will keep on rotating those, we will obtain the same kind of arrangement. Next, we are saying that we have two types of circular permutations. The first kind, it is, we are saying, in which the clockwise and anti-clockwise arrangements give rise to different permutations. And second, we are saying the clockwise and anti-clockwise arrangements, they give rise to the same permutations. So suppose we are talking about the situation that we have four persons A, B, C, D. We can ask them to sit in clockwise direction. We may get it is A, B, C and D. They may sit in this way. We are talking about these circular permutations over here. Or they may be sitting in this way, that it is A, B, C and D. So both these arrangements, they are representing the different arrangements. But suppose in place of persons, we are talking about, we are having four beads and we want to make a necklace. So we are having the situation that these four beads, these can be placed in this way. So it is immaterial to ask whether these four beads, these are arranged in clockwise or anti-clockwise direction. So this thing is immaterial over here. So we are talking about these two cases. This is the second case, that the clockwise and anti-clockwise arrangements give rise to the same permutation. And when we are talking about these persons, we are having the clockwise and anti-clockwise, they give rise to the different permutations. Next, we have results on circular permutations. The first result is that the number of circular permutation of n different objects is n minus 1 factorial. So we are saying, suppose we have n objects, we are writing it is the objects we have, it is 1, 2, 3, 4, so on up to n. So we want to find the number of circular permutations. So in place of circular permutations, I am writing all the permutations. Suppose I am fixing this 1 at the first place, then this we will have permutations related to 2, 3, 4, so on up to n. The second object over here, we are saying this 1 is fixed, this first element 1 is fixed. The rest of the elements we may have, it is 3, 2, 4, so on up to n. We may have another, likewise we may have 1 fixed at the first place. The rest of the elements we are saying it may be 3, 4, 2, so on up to n. We may have elements in this form. Now, in the second case, we are saying we have fixed the first element as 2. We will obtain the permutation over here. We have fixed the second element as 2. We will obtain the permutation over here. Likewise, it will continue. Third, we are saying we have fixed the first element as 3. For the remaining elements, we will have the permutations over here. Likewise, we will continue and go up to, in the last case, we are saying this nth element, it is at the first place, and we are having the permutations in this way, that it is 1, 2, 3, so on up to n minus 1. Then this first element n is fixed. We may have 2, 1, 3, so on up to n minus 1. And these things, they are continuing like this. Now, the total number of elements we have over here, we are talking about this case, that the total number of elements we have over here, it is n factorial. The number of rows we have, this is the first row, second row, third row, nth row. So we have total number of rows we have, that is equal to n. The total number of columns that we will have, when we are talking about column, we are saying this is first column, second column, third column. Likewise, if we continue, we are saying the total number of columns we will have, suppose it is C. So the value of C we have, it is n factorial over n, that is equal to n minus 1 factorial. And what this C is, we are saying if we fix this first position as 1, if we fix with any of these, we can fix with 1, we can fix this first position as 2, we can fix this first position as 3, then these all elements over here, this will correspond to the circular permutations, and the number of circular permutations we will have, it is n minus 1 factorial. Next result we have is the number of ways in which n persons can be seated around a table is n minus 1 factorial. So this thing is clear from this above result. So we are saying what we are going to do, we are going to fix the position of one person and we are going to arrange the remaining n minus 1 persons. So the number of arrangements we can have, it is n minus 1 factorial. Next is show that the number of ways in which n different beads can be arranged to form a necklace is 1 by 2 into n minus 1 factorial. So we have n different beads are there. So if we fix the position of the first bead, then the remaining n minus 1 beads, we are saying, they can be arranged in n minus 1 factorial ways. And when we are arranging these beads, we know that this is the case that there is no distinction between the clockwise and anti-clockwise arrangements. So the required number of ways, it will be half of this well. These are n minus 1 ways, so the required number of ways will be 1 by 2 into n minus 1 factorial, because there is no distinction between the clockwise and the anti-clockwise arrangement. In this case, we have already seen on our previous slides that when we are talking about, we have 4 persons A, B, C, D, then the arrangement A, B, C, D and the A, B, C, D. Both these arrangements, these are different. But when we are talking about 4 beads, both clockwise, either we arrange them in clockwise or we arrange them in anti-clockwise way, both these represent the same thing. So we are saying in this case we are having, these are the 2 different options. In this case we are having, this is the one arrangement we have. So basically we are saying it is half this value. So that is why this half is over there. Next is, in how many ways can 8 students be arranged in a line and in a circle? So when we are talking about the case in a line, it is 8 factorial ways. And when we are talking about the case in a circle, so it is 8 minus 1 factorial ways, that is equal to 7 factorial ways. And the values of these two terms, 8 factorial, it is 4032. And the value of 7 factorial we have, it is 5040. So these are the number of ways we have. Next is, if 20 persons were invited for a party, in how many ways can they and the host be seated in a circular, at a circular table? So the total number of persons we are saying, it is 20 persons are invited and there is a host. So the total number of persons we have, it is 21. We are talking about a circular table. So the number of ways we have, it is 21 minus 1 factorial, that is equal to 20 factorial. We are saying the total number of ways we have, it is 20 factorial. Next is, in how many of these ways will two particular persons be seated on either side of the host? So suppose we are saying that host is sitting at this place, this is the host, and we are having two particular persons who are sitting on either side, this is person 1 and this is person 2. We are considering this as one entity. Now how many persons are left which are to be arranged in this circular way? The number of persons we are left, it is 18, and these 18 persons we arrange in 18 factorial ways, and these 3 persons, host is fixed and these 2 can be kept in host over here. We can have 2 1 or we can have these 2 cases. So we are saying that the total number of ways we have, it is 2 into 18 factorial. These are the total number of ways that we will have when two particular persons, I think when two particular persons be seated on either side of the host. Next is, in how many ways can a party of 4 men and 4 women be seated at a circular table so that no 2 women are adjacent? So we are saying, suppose first of all we are talking about the 4 men which are going to sit. The first man, it is at this place, then a vacant seat is there, then another man is there, then a vacant seat is there, then another man is there, then a vacant seat is there, then another man is there, and then a vacant seat is there. So in how many ways these 4 men can be arranged? It is, we are talking about these 4, so they can be arranged in 3 factorial ways. Now we are talking about, we have 4 women and 4 vacant seats. The number of arrangements that we will have, that will be 4 factorial. We are saying 4 women are to be seated at these 4 places, 1, 2, 3 and 4. So we are saying the number of ways we have, it is 4 factorial ways. So the final answer we have, it is 3 factorial into 4 factorial, that is equal to 6 into 24, that is equal to 144 ways. Next we have is, find the number of ways in which 8 different beads can be arranged to form a necklace. So the formula for this we have, it is 1 by 2 into n minus 1 factorial. The value of n we have, it is 8. So the answer in this case we obtain, it is 1 by 2 into 7 factorial, and on solving this the value we will have, it is 2520. So these are the number of ways in which 8 different beads can be arranged to form a necklace. Next is, a round table conference is to be held between delegates of 20 countries. In how many ways can they be seated if 2 particular delegates may wish to sit together? So if we are saying we are having total 20 delegates are there, 2 want to sit together, we are saying 1 and 2 they want to sit together. Now the remaining are to be seated on this table. Suppose we have fixed the position of these 2, so these can be arranged in the form in 2 ways. These 2 can be arranged in 2 ways, 1 2 or 2 1, and rest of the 18 we are saying they can be arranged in 18 factorial ways. Now the position of these 2 is fixed and rest of them can be placed in 18 factorial ways. So the total number of ways we have, it is this 2 into 18 factorial. This is the answer. Next is, in how many ways can 7 persons sit around a table so that all shall not have the same neighbors in any 2 arrangements? So the total number of ways in which 7 persons can sit on a round table, it is 6 factorial ways. We have 6 factorial ways. Now the condition given to us is that they should not have the same neighbors. So we are saying, if in clockwise and anti-clockwise arrangements we are talking about, then each person will have the same neighbors. So we are talking about that we are not interested in different clockwise and anti-clockwise direction, these should correspond to the same thing. So the total number of ways we have, it is 1 by 2 into 6 factorial, and the answer we obtain, it is equal to 360. Next is 3 boys and 3 girls are to be seated around a table in a circle, and among them the boy X does not want any girl neighbor. This boy X, we are saying, he doesn't want any girl neighbor, and the girl Y does not want any boy neighbor. So we are saying the arrangement we can have over here, we are saying if X is at this point, this boy we are talking about is at this point, then on both sides of this boy it should be 2 boys, B1 and B2. And if we are talking about the girl Y, we are saying on both sides of this girl it should be girl. So we are talking about G1 and G2. We are talking about this case. So it is being asked that how many such arrangements are possible. So if we look at this first condition we are talking about, that on both sides, this portion we are talking about, there are 2 arrangements, either we are having boy 2 or boy 1, or we are having boy 1 and boy 2 and X is in between them. So the number of arrangements we have in this way, it is 2. Similarly for this girl, we are saying, for this girl when we are talking about, we are having the arrangement, it is G1 then Y then G2, or G2 then Y then G1. So the number of arrangements we have, it is 2. So the total number of arrangements we can have, it is equal to 4. So we can have 4 arrangements in this way.